Hi, Year 11s, this is Mr. Lim here again, and this is our video on pH calculations, the second level, so let's get started. We're going to do some calculations. Okay, so let's have a look. So if you mix two acidic solutions together, the total number of moles, and this is the moles, of hydrogen ions, and the total volume of the solution must be used, that makes sense, to determine the final concentration of hydrogen ions, and therefore the pH. Okay, so what you're effectively saying is that to work out the pH, you need the concentration of hydrogen ions. To work out the concentration of hydrogen ions, you need moles and volume. Okay, so when you add these two solutions together, you find out the total moles, total volume, then you get the final concentration, and then pH. So let's get started, and let's go walk through some of these things. All right, so here we have 20 mils of 0.2 mole per liter hydrochloric acid and 30 mils of 0.6 moles per liter nitric acid. Let's work out its final pH. So we can work out the number of moles of H plus, and this is where I always say that you need to put in like little bits of information or annotate your calculations from the HCl is equal to 4 times 10 to the negative 3 moles, which we're going to save on our calculators as A. All right, so that comes from the 20 mils and the 0.2 moles per liter. All right, then the number of moles of H plus from the HNO3 is equal to, let's just write this out, 0.6 times 0.03, which is the 30 mils and the 0.6 moles per liter, which is equal to 0.018 mole, which we'll call B. Okay, so now you've got the number of moles from both the hydrogens from the HCl and the HNO3. You can write the number of moles of H plus total, which will be equal to A plus B, which will be equal to 0.022 moles. Okay, now that you've got the total number of moles, we have to work out the concentration of those H plus ions. You can't just use the number of moles in the pH calculation because that would be wrong. You've got to use concentration. So you do 0.22, and what's the total volume? The total volume here is 50 mils. So remember to convert it into liters, and you get 0.244 moles per liter. And then you can solve for the pH using that, neg log 0.244, which happens to be 0.612. There's no units for pH. All right, 0.612 pH. All right, so that's the idea. You need to use the total number of moles and the total volume, and therefore work out the pH. Let's have a try of the next one. Okay, so now this one here, you've got something different. You're given pH to work out the concentration, and then you can work out the number of moles. Same, and then that one's just a normal one. So let's have a look. Number of moles from H plus from the HCl will be equal to 0.4 times 0.05, which happens to be 0.02 moles. We'll save that as A. The concentration of the H plus from the HNO3, see, because we're dealing with the H plus in both situations, we've got to annotate it to make it a bit more clear, is equal to 10 to the power of negative 3, which happens to be 1 times 10 to the power of negative 3, right, mole per liter. Then I can work out the number of moles of H plus from the HNO3, which happens to be 1 times 10 to the negative 3 times 0.09, which will be 9 times 10 to the negative 5 mole, which we'll call B, right? And therefore we can work out the total number of H plus ions, which will be, what will that be? 0.02009 mole. Work out the concentration, which will be 0.02009 over, what's the total volume? 140 mils, right? And that will be 0.1435 mole per liter. And then you can do the pH is equal to negative log 0.1435, which happens to be some value, 0.8143. All right, so that's that one there. Right, here's the last one, okay? The last one you have a go yourself, but the final answer is 0.878 as the pH, right? And then if you don't get this one, come and see me in class, right? Let's have a look at the next one. Okay, so if you mix an acidic solution with a neutral solution, the moles don't change, only the volume. Effectively, you're diluting it. Okay, so it's called a dilution. So let's go through some of the examples. All right, so first of all, let's work out the number of moles of H+, because what we've got is the 20 mils of 0.1 mole per liter HCl, and you're just going to add 80 mils of water to it. All right, so the number of moles of H plus is equal to, what is this, 0.1 times 0.02, which is equal to 2 times 10 to the negative 3 moles. Then I'm going to find its concentration, because I'm going to say that, okay, then that's the number of moles over its volume. What's the volume? 80 plus 20, so it's 100 mils, and so therefore it is 0.02, and the pH is equal to log 0.02, which is equal to 1.699. Okay, nice and easy. Okay. This one here is only different, so it looks very similar, but it's in the way that it's made up to 80 mils, which means that the total volume is 80 mils. Okay, so you can try this one yourself. It is 1.6 is the final pH. Okay, so instead of using 100 mils, you use 80 mils. Okay, then finally this one here. Let's walk through this one. What volume of water needs to be added to 20 mils of 0.1 mole per liter hydrochloric acid to form a solution with a pH of 3.4? So you're going to say, what volume of water do you need to add to this to dilute it to that value? So what information can we work out? Well, we can work out the concentration of H plus required. Okay, that's from the pH of 3.4. So we do 10 to the power of negative 3.4, which happens to be 3.98 times 10 to the negative 4 moles per liter. That's the concentration that we need. Okay, that's the concentration we need to get to. We need to add water to it until we get to that concentration. Right. We also can work out the number of moles that we have, or H plus that we have, from the 0.1 times 0.02, which happens to be, again, 2 times 10 to the negative 3 moles. Okay, so that's how much we have from the 20 mils. So therefore, we can say that what's the volume of this solution that we would need to have to get that concentration. So this is V is equal to N on C, which is a rearrangement of this N is equal to CV equation, right? So the N is 2.2 times 10 to the negative 3 over the concentration, 3.98 times 10 to the negative 4, and that happens to be 5.024 liters. Okay, so do we just add 5.024 liters? No, because we need to add it to get to that value. That's the volume that we need to have at the end. We started off with 20 mils. We need to add to get to that value, to 5.024 liters. So the volume of H2O added, or needed, which would be equal to 5.024. That's how much we need. Subtract how much we started with, which was 0.02, and you get 5.004 liters of water. All right, so that's how you would do that one. Okay, let's have a look at the next one. Okay, so if you add, now we're adding a acidic solution with a basic solution. They will react with each other and neutralize each other. Okay, but if you don't add them in the right amounts, one of them is going to be left over. In year 11, the acids will be in excess. Okay, so we're generally going to have the acids in excess, but in year 12, we're going to have the bases in excess, and you're going to have to work out how to use different calculations to get the pH from the excess hydroxide. But in year 11, the acids will be in excess, and so therefore the remaining hydrogen ions and the total volume will work out the pH of the solution. So let's try this one here. So first of all, we need to work out the number of moles of H plus from the HCl, which is, again, is equal to 2 times 10 to the negative 3, because Mr. Lim doesn't change numbers very often. And we're going to save that as A. Okay. Now we have to work out the number of moles of sodium hydroxide because that's what we've got. Okay, so that is 0.0001 times 0.08, which will happen to be 8 times 10 to the negative 6, 10 to the negative 6 moles. And you should recognize that the number of moles of OH will be equal to the number of moles of NaOH, because that's what we're dealing with, the hydroxide ions. Okay, you can write out an equation now. So you can either write out HCl plus NaOH and just write a molecular equation, not the ionic equation. Or you can write out the H plus OH minus goes to H2O. Both of those equations are fine, right? But you just need to work out the stoichiometric ratio between the hydrogen ions and the hydroxide ions, which happens to be here 1:1. So the number of moles of H plus, which will be consumed by the OH minus, will be equal to the number of moles, number of moles of OH minus times 1:1, which happens to be this value here, which we'll save as B. All right, so therefore the number of moles of H plus excess will be equal to A take away B. And I should probably have written in here, in fact I will write it in here. Okay, the number of moles of H plus have is greater than the number of moles of H plus consumed, therefore H plus in excess. You have to actually show that. That's the limiting reagent calculation from all the way in term 1, or term 2. I can't remember when we did it. Right. So then we have the number of moles of H plus excess will be equal to how much we have, subtract how much was used up, which will be equal to 1.992 times 10 to the negative 3 moles. Then we can work out the concentration of H plus excess, which will be equal to that value, 1.992 times 10 to the negative 3 over, what, 0.1, because we've got 100 mils in total, which happens to be 0.01992 mole per liter. And the pH from that will be equal to 1.7. Okay? All right. Let's try another one. Okay, so again, the exact same step, but the only difference is that you've got a pH here, so you have to convert this to a concentration, get the number of moles, get the number of moles. Okay, this is a bit tricky because the barium hydroxide is BaOH2, which means that you either have to multiply it by 2 to get the number of moles of OH minus, or you can do the stoichiometry between barium hydroxide and hydrochloric acid, but there should be a 2:1 ratio there. Okay, and I'll let you give it a go, but the final answer is pH is equal to 1.680. Okay, and if you don't get that value, you can come and ask in class and see how to do it. Right. Or actually, maybe I'll just write it out and then have it magically appear. Give me 1 second. Ta-da, magic. Here's the calculation. All right, so give that one a go. Hopefully you gave that one a go, and then let's have a look at the next one. Okay, this one here I won't do, but the answer is pH is equal to negative 0.141. Okay, so it's a negative value because there's quite acidic. There's a concentration higher than 1 mole per liter of excess hydrogen ions. Okay, so just please make sure that you give it a go, and if you can't work it out, then please ask in class. All right, that's it. Adios.